Welcome, everybody. Today we are going through the Unit 6 exercises. We have 3 of them to go through. I do have the exercise descriptions here up on the screen. So we're going to go through this one, and number 4. You can see like number 4 in particular has a bunch of steps to it, right? So that's what you're wondering why only 3 exercises. Um, the grand topic here is to work with lists, and I'm also going to fiddle a little bit with tuples in the process of kind of reinforcing the materials for this unit. Normally, I would code in the Spider IDE for this class, and in previous weeks I also demonstrated. I think for Unit 4 we demonstrated the Jupyter Notebook, which is a different format for working with Python, basically with what we call Python notebook files, which mixes the output and the code together. This week, I'm going to use a different IDE. You guys do not have to, but I just want to show you because I know I have people here that like to use different IDEs, and you might already be using this product from Microsoft called Visual Studio Code. If you look up Visual Studio online, this is Microsoft's like big IDE. And the one that I just went to here, this is the full-blown product though. And they are up to version 2026. And this is not the product I'm talking about, right? However, when you do really high-end coding, this is probably the best IDE out there. I think we've talked about this before, right? And the free version is the community version. But I usually dissuade students, at least for a class like this, for loading this product, because you download it and then you realize there's all these plugins. And Visual Studio 20 or Visual Studio, a full product, is kind of like downloading like a big video game that's got a bunch of DLCs, right? Like it's really easy to have build like a couple of hard drives with just like the downloadable content. So I dissuade people, but this does work for Python too. So you can download it, install the Python libraries and code, and it's probably got the best IntelliSense and autocomplete and stuff compared to any product, really. But they also have this version, which is Visual Studio Code. And once again, I know we've talked about this, so I'm making it kind of brief. But this is the more lightweight, extensible product, and you'll notice that it runs on all platforms. So if you're a Linux or Mac person, here you go, right? And whenever I'm on those platforms coding, this is my go-to product. A lot of people in the industry really like this product because it's open source. It's highly extensible, so people write all sorts of plugins and downloads and add-ons and tools that you can augment with it. It's got a really lively community that supports it as well. The other really killer thing about it is if you have a GitHub account, right? So I'm introducing you guys to this other thing, right? And some of you do and might be familiar with this, but there is this website called GitHub, which is GITHUB. You can go here and create a free account if you use your Gateway student email account, right? They see the .edu, right? And they give you a little higher level of access because you're an EDU person. And what I find really fascinating about this, what GitHub basically is an online repository for storing your code. So think of it as kind of like Google Drive for code. The only catch to it is you put your stuff out here, anybody can see it. If you don't want people to see it, you can pay, right? But if you use the free aspect of it, hey, whatever. There's some really neat aspects of this, though, because not only can I store my files here, I can take my IDE. If I have a better quality IDE, Visual Studio Code is one of those. If I was using PyCharm or regular Visual Studio or some other high-end IDE, a lot of those have tools built in that allow you to interface with your GitHub account. So you're storing your stuff in the cloud, you're pulling it from the cloud, you never have to store it on your own machine, right? And for professional developers looking for work, a lot of people that write a lot of code will they'll do a resume and they'll share their GitHub link so people can just go look at their work, right? It's a great place to store your work. Think about this. If you're putting your stuff on your Gateway Google Drive right now and storing it there, what happens when you're done with your degree and your account gets deleted? What happens to your files? Yeah, goodbye. right? So it might not be a bad idea to experiment with this platform. There's great tutorials out here about how to use it and stuff. But what I found, what's really interesting here, and a lot of people don't know this about GitHub, is they have built into it, right? Once you're signed in and connected and got all your API keys and all that stuff in place, they have this thing called code spaces, which basically allows you, and I'm just going to show you, I'm just going to bring up like one of these pre-built templates here. Notice they have one for Jupyter Notebook. This basically launches in your browser Visual Studio Code, and I can code right inside the browser. And it gets stored on GitHub. So I don't have to install anything, right? And I have a place to store my files. And it's free. So this is really kind of exciting, so if you think about like the fact that you can run an IDE in the cloud, the one thing I don't like about it is because you're using somebody else's free service, it's a little clunky and slow, but it does work. And it also has all the AI integration. So you can see there's a chat window here, and you can, choose various different AI models to interact with, and it's all inside this environment. Visual Studio Code, when you do install it on your machine, will also bring up an AI chat bot as well. I normally leave it off, but it is integrated, and you can interact with it, right? I don't really want to necessarily demonstrate that tool, but it really is a button click. You can turn it on and utilize it, and it helps you as you're coding, fix your code, upgrade your code, give you advice on your code or whatever, right? And it's kind of weird to like teach you guys the rudiments of programming and then show you, well, I can just have AI write your code. That's kind of weird. But in the professional workplace, it's already happening. So if you guys don't start getting into this mindset of like it's okay to use AI to help you fix your code or find issues or whatever, you're going to want to start changing that mindset, because when you're going to go out into the workplace, people are going to say, hey, have you ever used Copilot to help you code? Or have you ever used Codex or Claude or Gemini or whatever? And having that knowledge will be kind of instrumental. It's kind of a heavy thought, but this is the future that we're moving into. And it's okay. There was a time where we looked at Google and like, that's not like cheating. It's like, no, now it's just considered normal, right? And I think in 10 or 20 years, using AI tools to help you through things and just be normal, right? So you guys need to get geared up for that. I'm going to retire soon, so I don't have to worry about it as much. But you guys are moving forward into a world where if like you're not working with AI, you're going to be working for AI. I think is what's going to happen. All right. So I'm coding in this environment. And I know initially this is a little weird, but I'm going to kind of keep it sort of basic. And what I'm going to do here is I am going to show you a little bit of this interface on a really rudimentary level. This is not to push this product, but if you decide to try this product, the first thing I tell people is you want to start with file management always when you're working with coding. So you can connect it to your GitHub account if you have one, and if you don't, you can go ahead and create one. But I'm going to attach this to where I'm going to store my code for this week, which is in my Python class folder for Spring 26. And I'm creating a new folder for, this is Unit 6, right? And so I'm creating the folder, so now it's there. Then they have this little toolbar thing up here at the top, which is the file explorer, basically. And what I'm going to do is I'm going to open the folder I just created. Wrong class. There's Python, Spring, Unit 6. That's my folder. And so now in the sidebar here, I can see all the stuff in that folder, which of course is nothing, right? I haven't put anything in there yet, right? Whenever you use this product, they always throw this welcome screen in here, which I'll tell you what, I'm not a big fan of welcome screens because I always feel like coercing me into an action. But I just want you to notice the stuff that you can kind of do, right? Like you can create a new file, open a folder, clone a Git repository, which means go to your GitHub account, pull your code down, work on it locally, and then you can push it back into the repository when you're done. Or you can connect or whatever, right? So there's a bunch of different things that you can do. I'm just going to cancel that out. And what I'm going to do here on the sidebar is I'm going to click this first icon, which says new file. And we're working on exercise 6. I'm doing _1. And this is a Python file, so .py. And there you go. When you're working in this environment, you also have a secondary consideration. If you have not yet installed Python on your system, and I go to try to hit the run button, which is up here, it'll say, hey, you don't have any Python libraries, right? And it'll say, do you want me to install an extension? So one of the features of this product is they have which one of these is extensions? Right here. This is extensions. And ultimately you need to have a Python library available, and then some Python tools which will basically auto suggest as you kind of add them in. You can see some of these I have installed, some of them I don't, but they have all these crazy tools that you can kind of throw in just for Python. I'm just scrolling, and I'm sure I could scroll for an hour and it wouldn't stop. But the Python debugger and the ones that Microsoft recommends out of the box, if you're using Visual Studio Code, just say yes, install, right? And then if you want to find specific tools for other purposes, you can do that. All right, so I'm just showing you those are the extensions you might need. If you already have Python installed on your system, though, you might get a message like the one you see way down here in the corner. It's really easy to miss. See what it says? It says select Python interpreter. So this is really kind of an interesting aspect of this. So I'm going to click on that. And then way up at the top of the screen, kind of a clunky interface. I already have Python installed on my system, but this winter, as I was going into winter break, when I could come up here and I'd have a list of like 5 or 6 Python environments because I was doing so much work with AI, and I had like version 9 and version 10 and version 12 and version 13, and then I created virtual environments, and that's kind of a whole different rabbit hole. But when you come up here, you should see the Anaconda install. I can tell it's Anaconda. See, it says Anaconda right there, right? And they call it Conda, right? And that's my base environment. So that's what my operating system uses to run anything Python related. So I have like a video game or a piece of software that requires Python. I can use the same installation to interpret and run my Python code. All right, here's a caveat. For the stuff we're doing here, that's fine. So that's what I'm going to choose. But notice how they have this other option, which is create virtual environment. So Python coders who do a lot of advanced work often get concerned with the fact that I'm writing this heavy code, I'm writing it for a specific version of Python. I don't want to pollute the installation of Python that I already have on my system because my other software might stop working. So you take the environment, you make a copy of it, and then you run it separately. So we kind of like, if you guys are familiar with virtual machines, right? We're creating a virtual Python environment to run our code to not pollute our operating system. So a lot of coders do that, usually when they want to address very specific Python versions with certain features. Okay, so I'm just kind of giving you guys this headspace because especially AI data students, when we get to advanced levels of Python, what we discovered in our classes is we're doing this really heavy code. We're adding all these weird libraries. I'm just going to create a virtual environment because otherwise it's going to mess up my other environment, right? And that kind of becomes this routine that you go through. For now, I'm just going to choose the base environment. And so now I can run my code just to make sure my code actually works. I'm just going to come up here and do a really simple print statement and say, hey, whatever, and then I'm going to hit the run button. I just want to make sure that it works. And there it is. Right. Creates a bunch of ugly output, right? Whatever. It's a warning message from the Python installation, but it is working. There it is. There's your output right there. Okay. I also want to, and I don't want to like freak you guys out, but like, um, You guys see what I typed in there? I'm prompting my AI engine here. Please write me a program that sorts a list of integers in descending order. Also create a list with numbers to process. This is the world we're moving into, folks. Being a little slow. I'm not even sure which model I'm attached to right now as far as AI engines, but you see it's taking my prompt. Okay. It's telling me what it's doing. I don't know if you guys are catching. There's the code. Yeah, there's the wow factor, right? If you've never seen this before, right? And then it throws it into my program and I can keep it. There it is. Created my program for me. Now I'm going to run it. There you go. Homework's done. All right. This is what I'm just telling you right now. This is what I don't want you to do. And okay, if you were out working professionally and you were like, oh, I don't remember how to do this or whatever, and I need to figure out how to do that, or I need to speed up my work because I don't want to lose my job, you're going to do this, right? But where we are right now, learning fundamentals, I just want you guys to remember, I'm giving you all the answers anyhow. There's no reason to use AI to cheat, right? However, if you run into problems with your code, so I'll just give you an example, right? Let's say I do this. It's broken, right? I try to run it. Oh, it still works. That's Python for you, right? Python still makes it work. I mean, it's finding a problem, but it's not like a catastrophic. Oh, I didn't save it. That's why. Let's do a save, and then let's run it. Yeah, and it's not working, and it's throwing an error. And you'll notice with some of these tools, right? Do you guys notice that there's a fix and an explain? And this is one of the reasons I'm pointing this out, right? Maybe if it just explains it to you and you go, oh, I'm just missing the closing bracket. But the fact that you can also, trigger it to fix, I'm not sure why it's not fixing, whatever. But I can use the AI agent here to fix it. The one thing you should know is that these AI agents that are built in here do have limited usage. So if you keep hammering it all day long, after a while, it goes, sorry, you used up all your credits. And then what you do is you switch to a different AI model, is what most of us do. And I think, like, for example, right, it looks like I burned through my Claude or my GPT-5, but I can choose the models I want to use, and you can add models and whatever, right? So this is really kind of an interesting thing. Don't fear it. Play with it a little bit, right? And there will be times where using it is really, really appropriate. And then professionally, you probably will find a lot of purposes for it. But this is not what our exercise is. But I just want to show you how these tools work, introduce you to a new environment, and I want you to let go of the fear, right? Because moving into the future, and I say this once again with all integrity, that the world you guys are moving into professionally with code, whatever specialty area you get into, this is a contention, right? You're going to go into the workplace. I guarantee you in an interview, they're going to say, have you ever used an AI agent to help you code? Which one? How did it go? That kind of thing, because they're going to expect you to do it on the job. So don't wait till you graduate to figure it out. And there's good ways and bad ways to use it, of course. Let's read our programming prompt here. Let's actually get to coding, because I know I'm like kind of digressing here, but I think that information is pretty helpful especially for people that have never seen it before. And if you really kind of get like, wow, this is really cool, consider switching to the AI data program, right? We do a lot of really cool stuff like that in that program, and it's always advancing really quickly. All right, so here's the first programming prompt. I have it pre-copied here, so I'm going to paste it in. And you know what? I'm going to put it in the form of a comment. And I just grabbed it right from the Word document, right? So write a program that initiates a list with 10 random integers All right. And now see how like my view is cut off here? And let's do word wrap. There we go. And then prints 4 lines of output containing every element at an even index, every even element, all elements in reverse order, and only the first and last elements. So it's really 4 exercises. But how are we going to do this? Well, we'll figure it out. We're going to kind of do it in a number of different ways. One thing I will tell you is, since we just learned functions, you could write a function for each one of those and call the functions. That would be one approach, right? And I'm not necessarily going to proceed that way. I'm going to write it as a sequential program that does these. And then if you want, I can convert it into a function-driven program really quickly and show you guys how that's done. Right. And this is kind of my goal here. And I'm looking at the clock going, man, I'm talking too much. We're not going to get through these exercises, but hey, whatever. That's how life is. All right, let's start with some basics here. The first thing I notice is it says random integers. And I don't know if you guys remember, but a couple units back, I had an extra credit thing about random number generation. And I know some of you guys did it. It's a pretty easy one to do. So I'm going to do a little bit of random number generation here. So the first thing I'm going to do, and I'm going to zoom in a click here, I think, is I'm going to import the random number generator using this command. I'm not going to pull in the whole library. I just want the random integer generator for this. So randint is that method inside the random library. This is how that works. All right, so you need that to randomize your integers. We also, and this is just kind of like a weird thing, because I could hard code, because we're asked for like 10 random integers, and I could hard code the number 10 in there. And then what I tell people is, like, what if you want to try the same thing with like 100 integers? I could come in here, I could set a variable for 10 right now, and then later on, I could switch this to 100 or 1,000 and do the same thing with a bigger set of values. So this is basically a way for us to scale our program, is the way I think of it. So you can hard code the 10 if you want, but you can scale it up really easily by adding more. So like I would add that little caveat. This allows you to scale to much larger lists. That's probably a good way. And I should say, by simply changing this number. And you guys, of course, don't have to put that in. So, next thing that we want to do is we want to create an empty list. So I'm just simply going to create one called values, empty square brackets. Just, here's a thing with a bunch of containers in it, nothing in it right now, but there it is, ready to go. Next thing we want to do is we want to add random numbers to the list. So we don't want to like hard code them. I mean, initially you could hard code the values, like create your own list, put your own numbers in, and then just kind of do it that way. But it was a directive to create it randomly. So we're going to run a loop to do this. So like, because I want to fill a bunch of positions in the list, I could just run the randomizer function, over and over again. And so like the general approach, and here's the general approach, right? If I want to take the list called values and I want to add values to it, I could append, whatever thing I want to throw in. So if I want to append, 1 to the list, and I'm just trying to show you, right, how this works. So I'm going to print values. So I'm appending the number 1 to the list, and then I'm going to print it. So here's the run. And and I got a syntax error. What was my syntax error? Oh, I never saved it. So it's trying to compile the AI generated code from before. Okay, let's hit save and then run. All right, so there it is. All right, try that one more time. There it is. Okay. It took a couple clicks to make it work, but there's number 1 printed in raw list format. Just to show you, the append command puts whatever is inside the parentheses inside the list, right? But I don't want just any old number going in, right? I want a random number. So the way the random number generator works in Python for integers is I say rand int, set of parentheses, because that's a method or a function. And I wanted to generate random numbers that are integers between the values of 0 and 100. So randomly generate a number in that range. Right. So watch what happens now. I'm going to save, Control S to save. Here's my run. Okay, it did it. It generated the number 28. I run it again, generated the number 12. So it's working, right? But I want to do 10 values. So this will go into a loop. So I'm going to say for I in range, remember this stuff, right? The looping stuff. We're going to start at position 0 in the list, and we're going to go up to num int, which is 10. So the never reach 10, so it'll go from 0 to 9. Right? You guys remember all that stuff? Then, of course, we need a colon here at the end. And then this needs to be indented. So we're going to indent it. So this loop will run. It'll generate 10 random numbers. If I wanted to generate more, I just change this number up here. Okay. So here comes the run. Control S to save. Hit the run button. And there's my random list of numbers. I'm going to run it one more time. Not that I don't trust that it's random, but I don't trust that it's random. Here's proof that it is. This is goofy stuff. I mean, in principle, you just trust that it's random. Do you? Yeah, I like a little proof. So it's okay to run it a couple times. So there it is. I have a list of random values. Now, and this is a thing, right? So like this statement here, real frankly, is test print to see if things are working as expected. And I don't know if you guys are thinking about this, but this is a really common technique in programming. I just did something. Is it working? I don't know. Put it up on the screen. Let's see. I mean, just kind of common sense kind of stuff. So I really don't need this print command, but whenever I want to test what's going into that structure, I'm going to, uncomment that and I can see. Right. And you can do that anywhere in your program, by the way. All right. So let's adjust this a little bit. And I'm going to put in a statement here to just get us started off. Right. And just because it's generating random numbers and I'm going to do work with it, before I do work with it, I want to see what the list is so I can see if it did the stuff correctly. Right. I want to see the original list. Then I want to see the modified versions. So here's the original list of values. I am going to add a \n at the beginning and a \n at the end. So blank line above, blank line below. Here's my original list of numbers, and then we'll do the other stuff. All right, so that's kind of my thinking here. All right, not sure that it works. Okay, save it and run it. Am I running the old version or the current version? I'm not even sure. Old version, because it doesn't have these words in it. You got to save it. So here's one of the tricks here is you have to make sure you save. I think there's a way to turn on auto save when you compile, but I'm not going to dig into that right now. So there's a better example. The original list of values. It's nicely labeled, so I know what I'm looking at. All right, moving on. First directive. Display every even element at an even index, or display every element at an even index. So if I was looking at this list, right, this is 0 position. Is that even or odd? Even. Yeah. So it would print this, every other one basically. All right. So how would we make that happen? All right. Well, first thing I'm going to do is I'm just going to put a print statement in, and I'm using the old approach on purpose for outputting this. And this end command at the end of the statement leaves the cursor flashing there so that when I print out the information it prints out after it. The next print statement will print after it as opposed to the next line. So the process of printing all the stuff at even valued positions, that is a repetitive process. And what you guys are going to notice here is when we're working with lists and tuples or data structures, loops are a mechanism because we're traversing a structure. It's a repetitive process. So loops are highly integrated into the problem solving here. So I'm going to do a for I in range again. And then what are our starting values? If I'm going to start at the first even position, that's position 0. I am going to go all the way through the list. So I'm going to do num int. I don't know if you guys are catching something else about this product. I just type a letter or two and it auto completes it for me. You guys picking up on that? Yeah, way better than Spider. Way, 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 way better. Right. That's one of the reasons I like switching to it. And you know, in a way, when you first learn how to do that, it's like, oh, that's kind of like cheating. I don't have to remember anything. No, it helps you. It helps prevent you from making mistakes. Right. IntelliSense is just, it's kind of like you're typing an email and it corrects your grammar for you. Hey, good thing, not a bad thing, right? All right. So our first little trick here is how do we check if it were in the even position? I'm going to take if the value of position, oops, I put in curlies, in position I, oh no, wait a second, that's not right. This is not the right watch. I'm looking at the next solution. All right, backtrack. All right, this is correct. But what's the really, I don't know why I didn't catch this. What's the easiest way to traverse the structure? Yeah, I can count up by 2. So I can go through the array positions instead of like hitting every array position or list position, excuse me. I can just start at 0 and skip all the odd numbered ones pretty easily just by doing this. Okay, so once I do that, how do I then display the values? Here you go. And I want you to notice once again here that I use that end thing. And notice how I put end equals with the double quotes, but it's just space in there so the numbers don't touch each other. And it'll print all the numbers on one line. All right. And then I like a blank line at the end. So I'll come out of the for loop and I'll just print the blank line. All right. Control S to save. Here's the run. Right. Original list. Elements in even numbered positions. Looks good. Okay, so that was the first one. Moving on. The next directive is display only the even numbers in the list, right? So we'll start out with a little. Okay, so I'm going to correct this. That should have been my statement down here. This is like me looking at my solutions and messing up. And that top one should really say this. So I apologize for that. Even index positions, yes, right. The next one we're going to do is just even numbers. And so for this one, we're going to do, once again, a for loop. Start at position 0 again. We're going to go all the way up to the end of the list. So num int, here's my colon. And then we can run that if statement. So if the values, the item in the current position, if I mod that by 2 and that ends up equaling 0, I know it's an even number, right? And then I will do my output statement, which I'm just going to copy here, which looks like this. And notice I'm just going in there. I find, in this case, I'm just going to that position, print it, add a space after it, stay on the same line and keep typing. Control S to save. Here's the run, right? Original list. 2, 20, 86, 68, and 74 are all even numbers. Pretty slick. Okay, moving on. Coming back to the margin here. Next directive is display all elements in reverse order. Okay, this is a weird one. This is actually has a kind of a cool solution. So here's my display statement to start with. It's the label, right? And end command there to keep it on the same line. We're going to run a loop. Watch how this loop is engineered, though. I think this is really kind of cool. So we're still using the range command. And if I'm going in reverse order, do you guys remember from the Kahoot, what's the shortcut way to refer to the last position in the list? Yeah, I can just say -1. Okay, optionally, I could say, I could use the length function of values and then subtract 1 from it. So give me a length of 10, subtract 1 from it. So that would be 9. So it's starting position 9, right? But come on, you guys, isn't it so much easier to just type -1? Yeah, right. So you can see how that's cool. Man, I really fought that one at first, and I look back on it, but man, that was silly. All right. If I'm going to count down now, starting at position 9, I want to make it to position 0. But the way the range command works is I have to go 1 beyond it. And I'm going the opposite direction. I'm going from the end of the list to what? -1. Because our first index position is 0. I'll never reach it if I put 0 in. But if I put -1 in, it will go to 0. Isn't that weird? And then we're counting down, so we do -1. That is a really weird for statement. Highly unusual, right? And if you're doing the comparison, right? Remember, these we go from 0 to this, which is a 10, but the last position is a 9, and we're automatically counting up by 1, so I don't say 1 at the end. Here, we're going down from the last position. So this represents the last position, which is equivalent to the length of the number int -1. We just say -1 here. We want to get down to the 0 index position. We got to go 1 past it, -1, and we're counting down by 1. So if you wanted the explanation again, there it is. All right. And then we're just putting stuff on the screen. So I can just borrow this to put the stuff on the screen, because we're going to put everything on the screen. And then a blank print command for a blank line. Right, here's the Control S to save. And then here's the run. Oh. All right, didn't work. And I'm trying to look at my code and go, display. So it did this, but didn't do the loop. Let me run it one more time. Not that I'm doubting here, but somehow this print statement's not working. So where is our syntax broken? Well, we know it's nothing from above, and I don't see anything broken here. Okay. This part of it is not working. I'm really curious. Okay. Oh, now I'm looking at my solution. That's what the answer is. So we get a little. So number of integers -1 takes us to position 9. So that's the fix. Yeah. My mistake. I apologize. Okay, now let's try it. Wait. Control S to save first, then run. All right. Is this reversed? Yeah, it looks like it. One more of these exercises if you wish, or if you don't, doesn't matter. It's still assigned. The last directive is this. This is kind of a weird one. Display the first and the last element. Do you need a loop for this? All right. Okay. I'm going to dump 3 approaches on the screen. This is where the -1 thing comes into play, by the way. 3 different ways to accomplish this. If I want to print the first position, it's always going to be values 0 is what I'm printing. You go to first index position, pull the thing out and print it. Done. If I want to do the last position, take a look at the techniques here. I can take what I know is the length of it, which is 10, right? Number of int -1. So we go to index position 9. Or I can check the length of values if I don't know the length of it, subtract 1 from it. That also puts me in the same spot. Or I just use the -1. So here's why the -1 didn't work before, right? Because up here, it wasn't attributing it to index position, that's why. I don't know if you guys are feeling the vibe on that, right? And if I would have set up here, values square brackets -1, what number would it drop in here? Whatever was in the last position, not, right? So that's why it didn't work. All right, let's assure that it works. So here's the run. And you see with all of those, how they are working. Right. And keep in mind, every time I run this, the numbers on the previous ones are all different. Okay, that was exercise 6.1. Let's go ahead and make another new file here. This is going to be exercise 6_2. And let's look at the prompt. And in fact, you know what? Like, once again, I do have it, I think, pre-copied here. So let's just bring that in. I'm going to turn on my word wrap here. It says, write a program that reads numbers, so that implies input, right? And adds them to a list if they aren't already contained in the list. A nice little exercise. When the list contains 10 numbers, the program displays the contents and quits. And what I did last time I built this is I add a little comment at the top. Build the list of 10 unique values. All right. Once again, I'm setting a variable. This is optional, by the way, not necessary. You could hard code the 10. But I like to do this if I ever want to scale this up, right? And just to give you an example, like in our previous program, if I wanted it to do that with more than 10 numbers, let's say I wanted to do it with 100 numbers, right? I could just change that number to 100. Watch what happens with this. Control S, run, look at that list, right? And maybe you guys aren't even seeing it all. There it is. Here's the original list, 100 numbers. Numbers at even index positions, numbers that are even, display in reverse order. If you want to double check it, go for it. First and last number, all 3 different approaches. If I wanted to take this program and I'm like, okay, 100 was kind of cool, but let's make it 10,000. Right, and I've done this before and it had issues, but let's watch it. There it is, 10,000 numbers, randomly generated. You guys feeling this? All right. You see how easy it was to do that? I just changed one number and I'm scaling up, and boy, that looks like the Matrix or something. Create your own hacker movie. Write a loop that just prints numbers over and over again. Giving you guys crazy ideas, but I'm just saying. But I'm going to change that back to a 10 and save it. All right. So back here, then we're going to do the same approach. And once again, if you want to scale it, you can totally do that, or you can hard code the 10. We are going to preset a list. I'm going to call it values again, whatever. It's kind of being lazy. And then at some point, we want to prompt our user. And so think about this. If I want to prompt my user over and over again to enter a value to put into a list, we would use a loop, right? Because it's a repetitive action. So I'm going to use a while loop this time. And here's kind of my thinking on this. While the length of values is less than that number that so I could hard code 10 here, but while it's less than the number of nums, I'm going to run this loop. I'm going to put a colon here, we'll indent. And then we're going to set up a variable called x that's going to hold it. We're going to do an input prompt that says something like enter a number, like so. And you know what? We're going to want to convert it, right? It says nothing about whether it should be an integer or a floating point number. You guys pick up on that fact? So I'm going to be safe here, and I'm going to convert that input to a float. So I'm wrapping the float function or method technically around the input method. So type in a number, turn it into a floating point, we throw it into X, which is a temporary holding spot. All right. Then we're going to check that value, right? So if X, and this is really cool syntax here, watch this, not in, because before we were saying I in range, now we're saying not in. Isn't this really weird syntax? It's like the negation. So if X is not inside the values list, then I will add it to the list. I'm just going to say values, append, and what am I throwing in? X. There it is. Isn't that, I just love the syntax. It's so simple. Very, very simple. Right. Next, we're going to come back to the margin here. And what I'm going to do is I'm just going to do this little command. We're just going to show the list, right? So, all right, let's save this. Let's run it. And notice down here, I got my prompt. Enter number. All right. I'm just going to type in 10 numbers I know are different. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's 10 numbers. And there you are. Notice they're all floating point numbers on the way back out. All right. Run it again. And I'm going to take 1, 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 7, 7, 7, 7, 7, 7, 7. Times being obnoxious about it. 8, 9, and 0. And now I know I have 10. There you go. But you notice how the ones that were already in there were ignored? Proof that it works. I want you to look at the code though. I mean, there's hardly any code there that makes this logic work. That's kind of one of the weird aspects of this language. Very, very little code to get the mechanics to work. All right. Here's kind of a little side thing I kind of add to this because right now we're working with lists, right? And lists are, remember this keyword, mutable, right? Which means you can change them. I can add stuff to them. I can remove stuff from them. We haven't done that part yet, but we're about to. But you can also do this stuff with tuples. And what I did last time is just to show people, right? Like, you know, here's an example of a tuple. I just created a thing called values2. I put parentheses around it, right? And I'm just going to output. This is an example of the tuple, so it's going to print the whole thing. And then I can dig into a certain position and output one of the positions. And there you go. Or did it? Oh, enter a number. Still got to do that part. Interestingly, though, if I try to adjust the contents of values too, for example, values to dot append. And I want to throw in, I don't know, 6. Notice it's not giving, you guys notice it's not giving me an error? There's your error. And what's interesting about this type of error, this is not a syntax error. Because in principle, it kind of wants to work. It's a runtime error, so it doesn't throw the error until the code runs. Then it realizes that the data structure is broken. Now, I would say that I think if I did this in PyCharm or Visual Studio, which has a little bit better debuggers in it, it would have probably flagged it. I'm just throwing that out there as an idea, and I'm just going to say this won't work. Tuples are immutable, which stands for unable to change. That's what that stands for. All right, Control S to save. And we got another exercise here. So I'm going to create another file. This is exercise 6.4. And just heads up for those of you that are crunched for time. We have 1 minute of class left, and I'm going to keep coding until I'm done with this. So you're welcome to leave at any time. You won't hurt my feelings. And remember, it's already pre-recorded, and I'm going to put a fresh recording out there with this one. This is a multi-parter. So with this one, I'm probably going to refer to it here in the document, right? So write list functions, excuse me, that carry out the following tasks for a list of integers. For each function, provide a test program. Now, the way that I'm going to orchestrate this is I'm going to write one program that's got a main method. I'm going to write functions to handle each one of these bullet points. And then I'm going to call those functions from the master program to get them to execute. I am going to do this in kind of hurry up fashion because of our time constraint. So there's going to be a lot of copy pasting here. And so I'm going to go through this relatively quickly. So it says, write a list of functions, carry out the following tasks, yada, yada, yada. And then what I'm going to do is I have these little pieces already copied into my code, right? So we're going to go through each one of those. I want you to notice there's like 10 of these little sub bullets here. So it's going to take a little bit of time, but not too much. Here we go, folks. Back over here. Let's start by creating a list of numbers. Find a list of numbers. I'm just doing it really easy so I can remember it. I'm calling it 1_10. I'm going from 1 to 10. Take care. Later on, I'm going to add a couple more data structures here to work with. But for right now, I'm going to set up my main function like this. I'm going to put in a pass statement for now, right? You guys remember that? Then go way down, and then I'm going to call main at the bottom. And this is just kind of my nerdy, obsessive, compulsive, whatever you want to call it. I define the main function. I throw in a pass statement. I go to the bottom, call it to run, because here's what happens. Sometimes I forget to do that, and it never runs. I'm like, what the hell's going on? Type all this code, nothing's working. But that's kind of my workflow. All right. Now we're going to come in here and one by one tackle some of these problems. The first thing I'm going to do is I'm going to get rid of the pass statement. And I just want to display the original information. Okay. Just put it up on the screen. I want to see what those numbers are. Maybe I use a random number generator, whatever. Doesn't really matter. Okay. First task. Swap the first and last element in the list. And this is kind of like, okay, this is a weird comment here. And I want you to watch something that's really, really weird here. I can do this thing where I already have a list that's saved in this name, right? But I could take it, and if I want to take that list and put it into another variable, I could create a variable called data, right? And I can say equals 110. Okay, so that list that I have in 110, in principle, is now in a new variable called data. This is really kind of a weird thing that we're about to learn here, and this is called memory referencing. And it's kind of a mind blower, and you might not understand it right now, but I assure you, like 6 months or a year from now, whenever you get to be more of a Python expert, you'll understand this a little bit more. But what's really fascinating about this, right, is if I copy this list of numbers into this item, and I make a change to the data list, the 1 through 10 list is also changed. So this is called a reference thing. So when I make a copy in a brute force fashion like this, I've got two different variable names, but they're both pointing to the same object. Potato, potato, right? Same thing. So if I change that data set with one, the other one also changes. So that why am I even doing this? Because I want to have that original list of numbers. I want to make a copy of it, do some stuff to it, but then I don't want to have to recreate that list of numbers every time. See, that's kind of my thinking. So although this is a tempting approach, not really wise, unless you intend to change one set of data with two different variables. So what we do instead is we put the list function around something that's already a list, and then that creates a copy of the first list and puts it in the new list. So now I have two lists to work with. So I'm going to do that pretty much every time. You know, that's and there's another way to do it too. You can do it with a copy function, but that's okay. This will do that action. The next thing I want to do is I want to create a function, and I'm going to call it swap first last. So I'm switching the first and last things. And then this is a function I'm calling, and what am I going to send to that function? You notice I haven't defined it yet. Just keep that in mind. But what I'm going to send to it is the data, the copy of the list, right? And then eventually I'll put it up on the screen. And then, you know, I mean, I can put the print statement can go up on the screen right now, right? It doesn't really matter, right? But this function doesn't exist, right? Now, when I use regular Visual Studio, and this is kind of a really cool thing, I sometimes do this kind of approach intentionally, because if I don't have a function created and it recognizes that, okay, we're calling a function you don't have created. And in Visual Studio, there's a button, and I don't know if this will do the same thing. Yeah, it does. See that? I can generate the function. Oh, okay. So it wants me to add a thing. I'm not going to add it. But in regular Visual Studio, I can click that button. It just drops a new function in there that's empty, and then you tweak it. Now I've already named this, so I'm gonna come down here, and actually I'll probably do something goofy like this. Functions defined below. Right. And this is kind of my pattern, is I just put them all at the bottom. Ray and I were having a talk about how in the old days we used to put them at the top, right? Because we're thinking it's sequential. Yeah, that's, in principle, it is sequential in the main program body, but when it goes looking for a function, it can be anywhere as long as it can access it. So then we have to build that function, and I'm going to do this quickly now, right? So I'm going to define, and we're going to call it swap first last. We're going to send data to it. I'll just call it data here as well. Now, in other languages, I would never call it the same thing as the value that's being passed in. Python doesn't care, because once I put it into a function definition, it becomes a local variable. It's a different variable than the data that sits outside of it, if you guys remember. So I'm going to receive that data, which is a list, right? And then what I'm going to do is I'm going to look at the first position because I'm dealing with the first and last position here. So I'm going to the first position, position 0, storing it in a variable. Right. And the thinking here is if I have a list of, let's say, if I have a list, it's kind of like a bookshelf and books are crammed into the shelf and no other books fit. And I want to put the last book in the first position. I first got to pull that book out. I got to set it down somewhere temporarily, pull the other book out, move it to the last position, and then put that one in the first position. But I can't do it otherwise because I lose it. So it's got to be that temporary holding spot. But the data in, let's say, the first position, right, is going to get replaced with the data in the last position, which I can refer to with a -1. Last position goes to the first position. The first position went into a temporary holding spot. And then if I want to put that one in there, then I just take the last position where I can just say -1, right? Or what's our data structure name? Data length data -1. I could do it that way too, right? A number of different ways you could syntax that. This is the way I prefer to do it. It's the modern way, and it's what I strongly recommend. And then I take that book I put in the temporary spot, and so now I can test this, right? So one of these functions. Here's a save. Here's the run, right? The original list, right? After swapping first and last, notice how all the stuff in between is still in order, and the 1 and the 10 are switched. Moving on, right? So this pattern is going to continue now, and I'm going to accelerate my workflow just a little bit. So first thing I'll do is up in the main program body, we'll put in the directive, shift all the elements 1 to the right, and move the last element into the first position, right? So kind of shuffling out all over and take that last one and put it over. This time, notice I'm using a different approach. Notice this is an alternate way to copy a list without referencing the same memory position. And there's a copy command. So I can say list.copy. I don't know. I think the first approach is better. That's just me. Cleaner syntax. But either one of those approaches works. Then we're going to have this function called shift right. So I'm going to come down here and create that. So we're going to define shift right. Once again, we're going to send the data in there, which is a list, and then we're going to start doing the work. Here comes the function code. And I'm just going to copy this all in right now, folks. I hope you don't mind if we're trying to accelerate our speed here a little bit. All right. Pull in the data. We go to the last position because that one's got to get pulled out, right? We put it in a temporary holding spot. Actually, we're putting it in a spot called last. Okay, that just makes sense. Could call it temp, I guess. And then we run a loop. So we go from the length of the data -1, right? Last position, down to 0. We're going backwards. Now think about why we're going backwards. I don't want to move the thing out of the first position to the second position until I move the second position to the third and the third to the fourth, etc. Right? So I really should have start at the far end. If I already pull out the last position, now I can take the second last position, move it to the last. So I'm going backwards to do the maneuvers. Right? So then every time I do the maneuver, the current position gets the thing that was in the position preceding it. So I -1. Clever, right? I think so. Then we take the one that we temporarily put in last, put it there, and then that's the call. So let's run this one. Check it out. So these are in order. Last position goes first. And then we proceed from there. The one thing I will let you guys know is I have a meeting in 8 minutes. So I might have somebody popping into the session, and at which point I will pause the recording and come back and finish this. I'm just saying that in the recording right now, just so you guys know if it gets a little weird. You'll understand why. All right, next directive is this one. So I'm adding this up in the main program body here again. So replace all even elements with the number 0, copy the list, call the function, and show the output. But we need to create that function, replace even. Replace even looks like this. This is just a copy paste. I'm not going to code it out. We get the list in. So we go through it. So we go from the beginning to the end. And then if that position is even, we set the value to 0. That was the directive, right? Saving, running, right? So any even positioned item is now 0. Moving on. Some of these get a little bit weird, but I think it's kind of interesting because it does give you this opportunity to work with the mechanics of this stuff. I think it gives you a better grasp, at least I hope so. This one says replace each element except the first and the last by the larger of its 2 neighbors. So kind of a weird directive. Once again, copy, call the function, display the result. And I apologize here, I'm trying to find my solution on the other screen. All right, so here's my function for that. Right, so we receive the list, we start walking through the data structure. Notice how we're kind of going from position 1 now. So notice, like, why do we start at position 1? Because if we are replacing each element by the larger of its 2 neighbors, we can't start at the first position because the first position doesn't have 2 neighbors. So that's the why we're starting there. We still go to the end of the list, and then I just run the max function on it. You could write other code, but this will just look at the 2 values, one that precedes it, -1, one that follows it, +1, which is the bigger one, that goes in the current position. So I'm going to do Control S to save. Here comes the runtime, right, after replacing the neighbors. And if you logic through the numbers, this is correct. Now, what I'm going to do, folks, is I am going to pause this here for just a moment. And actually, I'm looking at the clock. Let's try to do at least one more here. Heck, I might be able to do the last 2. All right, let's try it. All right, so here's the next one. Remove the middle element if the list length is odd, or the middle 2 elements if the length is even. But now we got a problem, because I only have one list. One is even. I don't have an odd length one. So what I normally do with this is I create another list, and instead of going from 1 through 10, I'm going from 1 through 9. So one's even and one's odd. And the numbers are really easy to wrap your head around, which is why I do that. I'm saving. All right. So I'm going to make 2 copies, right? One of the 1 through 10 list, one of the 1 through 9 list. I'm going to do 2 separate function calls, one with each list, and 2 separate outputs, one with each list. I need to create that function, remove middle. Here comes that function. This is kind of an interesting one because this uses the pop command. So, and what I want to remind you, the pop command, what it does is it has the capability of removing things from a specific spot. What I think is really clever here, we're using integer division to get a whole number answer. And if you start to analyze this, right, if I integer divide by 2 and I don't have a remainder, is kind of what we're shooting for here. But we're taking the length. So if the length is 9 and I divide by 2, what number do I get? Yeah, 4.5. But with integer division, it would give me 4, right? So it eliminates the 0.5. That's what it does. And so if the length is odd, it will pop the number that it fits in the middle with the 0.5. If not, it has to pop two of them to make that work. Let's run this and you'll see what I mean. So here's the Control S, and then here's the run. And notice down here that we have the middle elements. And notice how it did it accurately, right? So here it removed the 5. Here, because it was even, it removed 5 and 6. All right, you got one more here to do, and maybe I can do it before my next meeting starts. We'll see. And here's the last directive. Move all the elements to the front, otherwise preserving the order of all even elements to the front, right? Otherwise preserving the order. So with this one, this has a little bit more complicated syntax, but here is the solution for that one, folks. So I have like variables that monitor the positions. And then while the position is less than the length, I run this if statement to see if the item is even or not. If it's even, then we pop it out of the current position, store it in a temporary variable, and then we insert it. And the way the insert command works, and you can look this one up in the lecture materials, it'll give me that position where I'm putting it, which is the even position number, and then what's it putting in that spot, whatever we put into the temporary variable, and then we're incrementing the even position by 1, so the next time it goes to the next spot. Otherwise, we're incrementing the position by 1, and so we're running like 2 counters here, basically, as we're looping through. That's kind of a very simplistic explanation, but here goes the run, and there it is. Notice 2, 4, 6, 8, 10, and the odd numbers are left in order. Kind of a clever little algorithm. All right, folks, those are the solutions for this unit, and this video ends